Hello class, welcome once again. We're going to continue our discussion on the solvable groups of trigonometric integrals. So last time we discussed group 1 and we have 3 cases in group 1 and also group 2. There are also 3 cases. So for group 3, there are also 3 cases here. So the group 3 is in the form of this one. Same condition, m and or n are positive integers. Okay, so we have 3 cases here as mentioned in the previous video. So this is case 1, case 2, okay, and then case 3. So today I'm going to give you just one example for case 1, and the rest I think I would like you to do some exercises for case 2 and case 3. You just select from whatever resources that you have, select those problems that are related to case 2 of group 2 and also case 3 of group 2. Alright, so I'll give you one example for case 1. So for case 1, in case 1 class, the condition is that m is odd. Okay, so m is odd. Okay, so I will write here for case 1. So let's summarize case 1. So number 1, this is the summary for case 1 of group number 3. M is odd. Alright, so when m is odd, what shall we do next after finding this? M is odd, so we need to factor out. Cosecant u times cotangent u du. Okay, so this is what we are going to do after finding m is odd, and after that we need to change what? So we need to change the remaining cotangent. Cotangent, we need to change this to cosecant. Alright, so how to do that? We need to use the identity, that is cotangent squared u equal to cosecant squared u minus 1. So that is how to change the remaining cotangent to cosecant by using this identity. Okay, so for example, if say you're given integral of cotangent cube x multiplied by cosecant to the 4th x dx. Okay, so looking at the exponent of cotangent, where this corresponds to m, so we can say that the exponent of cotangent here is 3, which is odd. So this is case 1. So what shall we do after finding that this is odd? We have to factor out this cosecant u cotangent u du. Okay, so what we are going to do is to factor or express this cotangent cube x into two factors where we can get the cotangent of x, and so do with this one so that we can get the cosecant, this portion here, cosecant u. So out of this we also have to produce cosecant u or cosecant x from this given. Alright, so we can rewrite the given integral as, so I will put my equal sign here, integral of cotangent squared x multiplied by cotangent x. Okay, so cotangent squared x times cotangent x is equal to cotangent cube x. Then this cosecant, we can rewrite this as cosecant cube x then multiplied by cosecant x dx. Okay, so that is now our new integral function. So this time we are going to combine so that we can factor out this cotangent x, then the cosecant x, as well as the dx, and rearranging them because they're just products, no multiplication, so you can interchange their position. So we can rewrite this as integral of cotangent squared x, then write this first, times cosecant cube x, then rearranging so that we can follow this format, cosecant u cotangent u du. So that is the part of the integrand that we are going to factor out. So writing cosecant first before cotangent, so we have cosecant x times this one, cotangent x, and don't forget to write dx. Okay, so now we are isolating this or separating this one, the cosecant x cotangent x dx. So we are now factoring out this. Okay, factor out cosecant u cotangent u du. So that is what is meant by this one, so that we can focus now on these two factors. So this is equal to integral of, and the next thing to do is to change the cotangent to cosecant using this identity. Okay, so instead of writing cotangent squared, we have cotangent squared here, so we have to write this, its identity. So we can write this as cosecant squared x minus 1, then multiplied by this cosecant cube x, and of course this one, this factor, cosecant. Okay, I'll just use another color. Just to distinguish class from the other factors. So we can write this as this part here is just for cotangent, then write this, you have cosecant cube x, then also this one, whole thing, cosecant x cotangent x dx. Then after that, we have to multiply, we have to multiply the whole thing, this whole thing, we have to multiply to each term. So there are two terms here, we have first term, second term. So the whole thing here is you have to multiply it here. So this is now equal to the integral of, we have cosecant squared x multiplied with cosecant cube x, so that would be cosecant, this becomes 2 and 3, so that is 5, right? So cosecant to the 5th power of x, then you write the rest, this one. So multiplied by cosecant x cotangent x dx, and then we will put this inside the parentheses because we will distribute this integral sign later on. And this whole thing here, we have to multiply it by its second term of this quantity. So this is the first term of this quantity, we multiplied it by this one, this is the result. Okay, then after that, same thing, we have to multiply to the, or by the second term. So this is negative, so the whole thing here multiplied by negative 1, so that's negative. Okay, so negative cosecant cube x times cosecant x times cotangent x, then the whole thing is multiplied by dx. Okay, then distributing the integral sign and also the dx, so we have to distribute this integral sign to each of this term. This is the first term, second term. So our function now, our integral function now is integral of cosecant to the 5th power x multiplied by this, so cosecant x times cotangent x. Sorry class, it should not have dx yet here, so we have to take this out first because we put the dx outside the parentheses. It means that the whole thing here should be multiplied by dx later on. Okay, so this time we distribute the integral sign and now distribute also the dx. So this is the time that we write dx. Okay, then minus, so distribute this integral sign also for the second term. So integral of cosecant cube x times cosecant x times cotangent x and dx. Okay, so do you have any questions so far? Were you following? Okay, so let me adjust my camera. Now we have, in our differential calculus, we have this formula class, if you can still remember. Now from our differential calculus, we have the derivative of cosecant u with respect to u. So this is equivalent to minus or negative cosecant u cotangent u. Okay, I hope you still remember that formula. Or if you multiply both sides by du, so we have the differential of cosecant u equal to minus cosecant u times cotangent u du. Okay, so we have to make use of this formula class. Now if you look at the expression on our first term, we have this term cosecant x cotangent x dx. And also in the second term, we have cosecant x cotangent x dx. So it follows this format, right? It follows this. Only that we have negative here. Okay? So as in group number 2, case 2, we have to produce something that we can use the power formula. Now if you look at, or if you examine the given class, the resulting integral functions, so we have here derivative of cosecant u, and then this is the result, right? So it seems that if we let this part here as our u, then we have here it's du, more or less, no, except for the sign, but we can do something about it later on. Okay, so if we by the way, the exponent here, or the degree here, our n is equal to 5, and our n here is equal to 3. Now if we are going to let u, if we let u be equal to this one, cosecant x, then when you differentiate u with respect to x, or if you find the differential of u, using this formula, so we can say that the derivative of u with respect to x is equal to, so using this formula, equal to minus cosecant x times cotangent x, right? Now if you're going to cross multiply dx, or multiply both sides by dx, then we have du equal to minus cosecant x cotangent x dx, right? And so do with the other, or the next, or the second term. So we have also u here, which is equal to cosecant x, then finding its du, so same as this one, so this is minus cosecant x cotangent x dx. Alright, but what we are looking for here is the cosecant x cotangent x dx. If this is our u and this is our du, so this is cosecant x cotangent x dx. So since this is negative, so we have to produce something that is positive, that is the same as this one. So what we're going to do, we have to multiply both sides of this equation by -1. Okay, and so do with this one. So if we multiply this by -1, so we have now negative du equal to, so this becomes positive now. So this becomes positive cosecant x cotangent x dx. Okay, and also here we have negative du. When you multiply this equation both sides by -1, so this becomes negative du, and the negative here becomes positive cosecant x cotangent x dx. Alright, so I will continue here in the next board. Alright, now if you are going to substitute, so substituting, so equals integral of, so instead of writing cosecant x, since we let cosecant x equal to u, so we write it as integral of u, then n, still n, that is equal to 5. So integral of u to the n, or u to the 5th power, then minus, for this part here, minus integral of, so again, we have cosecant x here, where cosecant x is equal to u. So this is u, and then the exponent, which is equal to 3. So u cubed. Okay? But to make use of the power formula, we need to have its du. Okay? So we just substitute the u part of the function, integral function. So we also replace, since we replace or change cosecant x by u, we also have to change this. So what is this equal to? So this is equal to, here, this is negative, equal to negative du, right? So instead of writing this cosecant x cotangent x dx, so we have to write, because cosecant x cotangent x dx is equal to negative du. So multiply this by negative du. Okay? Then minus integral of the second term, which is also u, cosecant x cube or cosecant cube x. We let the cosecant x equal to u, so that is also u. Then the exponent is equal to 3. And then we have this part, cosecant x cotangent x dx, which is equivalent to negative du, right? So this one here, which is equal to this one here. So this is what we are going to replace by its equivalent, which is the negative du. So this is times negative du, similar to our first term. So make sure that you put that inside the parentheses, otherwise you might wrongly read it as use u to the fifth minus du. So be careful. Okay, and then rewriting it, this is negative, so positive times negative, so this will be negative. You can put the negative outside integral. So you have u to the fifth power times du, then minus, then you put the negative outside, so this becomes minus minus, so minus minus, that becomes plus, the integral of u to the third power times du. Okay, so that is now the resulting function, integral function. Then using the power rule, so our power rule is integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. So we have to make use of that power formula. Okay, so using the power formula, so this is now minus u to the sixth power divided by 6 plus u to the fourth power divided by 4, then plus c. Okay, or we can write this as negative 1 over 6 times u to the sixth power plus 1/4 u to the fourth power, then plus c. Then substituting the value of u, our u is equal to, what is our u? Our u is equal to this one, equal to cosecant x. Our u is equal to cosecant x. And so do with this one here for the second term. So substituting, so this is minus 1 over 6. Then substitute the value of u, which is cosecant x. This is our u, then raised to a power. Okay, raised to a power 6. Then plus 1/4. U is cosecant x raised to a power 4 plus c. Or we can rewrite this as minus 1 over 6 cosecant x to the sixth power. So you can put the power here between c and x, and plus 1/4 cosecant x to the fourth power, then plus c. So this is our final answer. Okay, any question? So I hope, class, that you have understood our discussion here for this topic. This is really similar to our group number 2, case 1. All right. So thank you very much and hope to see you again in our next video. Bye.